Okay, this is lesson 1.1, video 11, theorem 1.8. This is the last theorem for this lesson. So we're going to look at theorem part I. For every number a, the equality a over 1 equals a holds. So let's take a look at the proof for that. So we're saying that a equals 2a over 1. All right. So we also know that if we had a over n, that'd be a times n to the negative 1 power. So we could do that for 1 as well. So this would be a times the reciprocal of 1. And so if we multiply 1 to both sides, let's say we multiplied 1 and we multiplied 1. And then through the associative property, so 1 times a we said is a. So through the associative property, a times reciprocal 1 times 1. Okay, so that's the same thing as if we said a times 1 over 1. Or another way to write this is the reciprocal of 1 times 1. So this all becomes 1. And we get a equals a. And so a over 1 equals a holds. We've proven that. Okay, so now let's take a look at II, part II. And that states if a does not equal 0, then a over a equals 1. Okay, so we have if a does not equal 0, then a over a does not equal 0 either. So we put a, so therefore a times, this would be a to the negative 1 power does not equal 0. So then we can say that a times its reciprocal doesn't equal 0. And so these two cancel out and we get 1. Well, 1 doesn't equal 0, so that holds. Now, this would be known as proof by contradiction, where we're saying that if a doesn't equal 1, if we put in a over a, and a doesn't equal 0, then we can't have 0 over 0 here. So we're saying a over a is a times reciprocal of a, comes out to be 1, and that holds. And so that's our proof. And that's all there is for that one.